In this presentation, we're going to be looking at guided liquid simulations in Bifrost using Maya 2016. Guided simulations lets you drive the behavior of liquids either using a low-res cached simulation or an animated mesh object. In this example, we're going to be using a deforming polygon mesh of some ocean waves to guide our liquid simulation. This gives you artistic control over the basic shape of the liquid, while using the simulation to create splashes and other fine details. Only the liquid on the top of the surface is simulated, allowing for higher resolution settings with less memory and faster compute times. So the process of setting up a liquid simulation inside of Maya is actually pretty straightforward. All you have to do is select an object that you want to be a liquid and go up to the Bifrost menu and simply create the liquid from it. As soon as we do that, you'll notice that Maya automatically fills the full volume of that with flipped particles. This isn't exactly what we want. We only want the simulation to happen on the top of the surface, so we're going to go ahead and set up the guided workflow now. We're actually going to be using the same piece of geometry that we're emitting from as our guide shape. So I'm just going to add that into my selection, go to the Bifrost menu one more time, and just define that as the guide. With that done, the next thing that we need to do is add in a collision object or tank to hold the liquid. So we'll select both the collision object and the Bifrost container, go up to the Bifrost menu, and again, specify that as a collider. So now that we've done that, the next step is to go into our attribute editor for our Bifrost liquid and just start to modify a few of the parameters. So we're going to go ahead and first of all, turn on the fact that we want this to be a liquid simulation that's being driven by a guide. We're also going to turn off spatial adaptivity. We don't need it for this example. So with that done, we can go ahead and rewind this one more time. And you'll notice that as soon as we rewind that and we look down the side of our scene, that these particles now only exist on the top of the surface. Now these are digging down pretty deep. They're going down slightly deeper than I want. I want those to adhere to that surface a little bit tighter. So I'm going to go into my input settings and just change that min simulation depth to a slightly lower value. So now that we've done that, let's go ahead and jump over to the liquid shape, which again is going to allow us to interact with the particles that are being used to display what this liquid is inside of our viewport. And I'm just going to increase the size of those guys a little bit so they're a little bit easier to see. And maybe we'll jump down to the remap color section and we'll start to change some of these default colors to stuff that kind of matches our scene a little bit better. So we'll go ahead and grab something like that for that guy, maybe drop that threshold down a little bit so that it's a little bit easier for those guys to get bright where the velocity is going to be high once the simulation starts. And while we're here and we have this Bifrost liquid selected, I'm actually going to go ahead and add on top of that a Bifrost foam model to get some nice little white caps and things like that happening. So we can go ahead and jump back into that Bifrost liquid one more time. And let's just queue this all up and we'll just hit go and let our simulation start to process. So Maya sends the information off to Bifrost to be computed. Bifrost lives outside of Maya. It starts to do the simulation and send that information back into Maya in the form of a scratch disk. And you can see that as that background process is happening, we've already got 10 frames inside of here. So notice how quickly that guide shape starts to influence the overall movement of those flipped particles. They really start to adhere to that surface automatically right away. It's really a pretty awesome workflow. So as that's processing in the background, I want to draw your attention to a few other things. Let's look at this QuickTime movie. And what this is showing is different values that have been set for the min sim depth. So the min sim depth really does contribute a good bit to the overall look and feel of how your simulation is going to end up. So obviously the smaller the min sim depth, which is over here on the right-hand side, the tighter those particles adhere to that guide shape. And as the numbers start to increase, like the one directly to its left to a value of 1.5, the depth's a little bit deeper. We start to get a little bit more subtle detail on top of the surface here. So we're getting more waves kind of arching over and more splashes and things like that. And as that depth grows in size, we start to add more chaos into the scene here. This is at a value of 2 up here in the upper right hand corner, obviously a lot different looking than the one that's at a value of 1 that's directly below it. And then to the left is one with a value of 3, and at that point they're just going bananas. But this gives you a good understanding of what that min depth does. This is one of those controls that as an artist you can really fine tune exactly how much you want that guide to influence the overall shape of your simulation. So let's jump back into Maya now. And let's kind of scrub through here and see what we're getting. So as this kind of starts to play back here, those white caps are a little bit heavy. So we're just going to jump over to the foam model for those guys. And I'm just going to remap that foam particle a little bit. We'll make them a little bigger so they're a little easier to see. But I'm going to change their opacity so that they're being driven by density also. So we'll just switch that to density, and we'll just remap those guys down to maybe something like a value of 7 or something like that, and maybe spike that up a little bit so that we can start to get those particles sort of sitting there in that area. So as this starts to play back in the background, I can start to scrub through this, and you get a good sense of how that simulation is really adhering to that guide shape. Really looks pretty awesome. All right, so one more thing that I want to do really quickly is just isolate my view here. We'll just jump over to a wireframe view and just click the isolate select. And I can kind of scrub you through this a little bit as you get a sense of what it looks like without any of the other geometry in the scene. So it's a really quick example of what the guided sim workflow inside of Maya brings to the table. Let's go ahead and look at what the finished results look like after we kick these guys off to Mental Ray. So we'll just jump back to QuickTime one more time. So what we've got in this video is the waves starting off completely flat and then animating up. The background is all based on geometry. The foreground is all using guided sim that's using that same geometry as the background geometry is actually the same piece of geometry that's driving the liquid simulation. And then obviously as the waves start to get a little crazy, that Bifrost foam model starts to kick on and we get all the nice white caps and things like that. But obviously the background's geometry based, the foreground's a liquid sim being derived from or guided by that background geometry. So that's just a quick walkthrough of the guided simulation workflow for Bifrost inside of Maya 2016. Thanks a lot for taking the time to check it out. Cheers.